This is section 8.4 on vectors. It shows a picture here of what a vector looks like. It is a line, well, it's a ray. So the vector is a plane, is a line segment with assigned direction, so it's like a ray. There's an initial point and a terminal point. Those of you that are in physics, this next couple sections should probably be a little bit easier for you. And then we get a picture of what the sum of vectors are. I'm not going to read through all this. You guys are fully capable of reading yourselves of what this stuff is. Here's a whole bunch of pictures here of what vectors look like, and positive vectors, negative vectors, different lengths of vectors. Then it shows the difference of vectors. It's the same thing as adding a negative vector. So down here is actually how to find the component form of a vector. Now these are not, these little things right here, they are not parentheses, but they are like arrowheads. Okay, if you can't really tell in the blue box, that is what they are. They're actually like, they look like arrowheads. And that's how you find the component form. You use the initial point in find the difference between the x terms, take the initial terminal point, and then find the difference between the y terms. So if we come down to our first example, it says find the vector u with the initial point -5,4 and terminal point 4,8. So I'm going to label it u. This is for part A. So now we're using our little arrowheads. And it's always terminal minus initial. Always. Terminal minus initial. So it'll be 4 minus -5 for the x's. And then 8 minus 4 for the y's. 4 minus -5 will give us 9, and 8 minus 4 is 4. So our component form for vector u is 9, 4. Part B says if the vector is 4, 7, and is sketched with an initial point of 4, 5, what's the terminal point? So we're going backwards this time. So instead of subtracting, we should add them together. We'll label it V. Oh, we wanted the terminal point, so it actually doesn't have a label. So for the x's, we're going to add the two x components, giving us 8. And for the y's, we're going to add the two y components, 7 plus 5, and that'll give us 12. So our terminal point is right there, 8, 12. The magnitude or length, so the length is also called a magnitude. The magnitude or length of a vector is given to this equation where you have a squared plus b squared. A squared plus b squared, the a's and the b's come from the component form of the vector. It is also shown with absolute value symbols. It's not the absolute value of the vector. It's a symbol similar like absolute value, but it means now magnitude or length. So if we want to find the magnitude of u, we're going to take the square root of each part, 4 squared plus 0 squared. And this gives us 4. If we try part B, we're doing the square root of 3 squared plus -2 squared. And this gives us the square root of 13. And lastly, part C, square root of 12 13ths squared plus 5, oh, that's a squared, 5 13ths squared. Well, the numerators, isn't that like a Pythagorean triple? We get 13 13ths squared, which ends up being, oh, I don't want that, 13 over 169 over 169, which is just 1. Square root of 1 is 1. Next, we have the algebraic operations on vectors. You can add them, you could subtract them, and you could distribute, so to speak, a constant in. So if our vector u is 4, 5, and our vector v is -3, 4, we want to find 2u minus 3v. These are two separate questions, okay? So we're going to do that 2u minus 3v first. So I'm going to double u. Oh, I'll just double it by So this gives us 8, 10. And I'm going to do 3 times v. And this gives us negative 9 twelfths. And we are subtracting them. So 2u minus 3v. We're going to do component part with component part. So the fronts together, the backs together. 8 minus negative 9, and then 10 minus 12. 8 minus negative 9 is 17. 10 minus 12 is negative 2. All right, then we have 3u minus 2v. Well, 3u, if I triple my u vector, it becomes 12 fifteenths. Not fifteenths, you know what I mean, 12 fifteenths. If I double my v vector, it'll be negative 6, 8. And again, I am subtracting 3u minus 2v, u minus 2v, and we get 12 minus negative 6, which is 18, 15 minus 8, which is 7. Then we have our properties of vectors. Our properties are the same properties that we have. We have a commutative property, associative property, property of 0, inverse property, and the last one is the length using like a constant, multiplying a constant in. All right, onward we go. A vector of a unit length of 1 is called a unit vector. These are 2 popular unit vectors, i's and j's. So instead of writing vectors in a component form with those like arrowheads, they can be written using i's and j's. And it'll say, the question will say, write it in terms of i's and j's. So instead of writing them with the arrowheads, you just take out the arrowhead, stick an I in front of the first term, stick a J in front of the second term. And it's a plus sign. Unless they're negative, then they're minus signs. So if uv, they want to write 2u plus 5v. Well, it's double u. W becomes 10, 6. Times v by 5, which is negative 20, 30. And I'm adding them. So 2u plus 5v is negative 10, 36. But written as i's and j's, take out the arrowheads, stick an I in front of behind the first term and a j in front of the last term, or behind the last term. All right, then we're on to direction angles. This is if we have an initial point at the origin, and then theta is the smallest positive angle in standard form. Okay, so we have this vector here, whichever way you write it. Okay, this is another way that we can represent it. Okay, here we can find our direction angle theta given this piece. All right, down we are at the examples. Components and direction vectors. A vector v is length 4 and direction of pi over 6, which is 30. Write v in terms of I and j. Well, to get a, to get the a part, it is a length of 4, which is what that absolute value sign looks like. So 4 cosine pi over 6, pi over 6. And this comes out to be 2 square root 3. And then b is 4 sine pi over 6, which this comes out to be 2. So written in component form is 2 square root 3i plus 2j. Stick your i's and j's in there. And this one says find the direction of the vector u if it equals negative square root 2 over 2i plus j. We want to know the direction, which I don't have on my paper. I have the magnitude. I want to say there's a formula for that that I don't have on here. Okay. Well, we'll find the direction of U. We'll just change it to magnitude. I don't know why. I think I meant to change this. I don't know if it's changed in your notes or not, but I'm pretty sure I meant to change this to magnitude. Change this to magnitude. Sorry about that. All right, if I want to find the magnitude, I'm finding my length, which we're going to square negative radical 2 over 2 plus 1. That's really what's in front of that j. Square that. This comes out being 6/4 underneath the square root, which does not look nice. You can't even break square root 6 down, so that stays, but the square root of 4 is positive 2. So that's the top. Bottom. That's the bottom. The velocity of a moving object is modeled by the vector, whose direction is the direction of motion. That has to do with the next page. This is your physics stuff right back here. This last piece. An airplane heads due north at 280. That means if it's going due north this way, our vector for the airplane would be 0 to 80. Okay, because it's not going left or right at all. It's going just straight up, 280. Then it says it experiences a 38 mile per hour crosswind flowing in a direction of north 60 east. I need another picture. So north 60 east is actually right here. This is the 60 piece, but an actual vector is from this part up, which is 30. So we're actually going to use 30 degrees, not the 60 degrees. So to find the wind, which is that stuff right there, I'll write that over here. Wind, we'll label it U. It's a speed of 38 cosine 30, and then that's for the first piece. I'm running out of room. Comma 38 sine 30 is for the second piece, which this comes out to be, so U is actually equal to 19 square root 3 and 19. All right, and they want to know, find the true velocity of the airplane. Well, you have to add the two together. The speed of the airplane plus the wind will give us the true velocity of it. So we're going to add the U plus the V. And if you add those two together, we get 19 square root 3 and 299 from the 280 and the 19. That's part of, well, that's not the true speed, that's the vector. This is the vector of speed. So that includes wind plus airplane. All right, so to find the actual true speed of it, we're going to do the magnitude. (19 square root 3 squared plus 299 squared). Punch that in the calculator, you get 300.81 miles per hour. All right, now we have a boat. A woman launches a boat from one shore of a straight river and wants to land at a point directly on the opposite shore. If the speed of the boat in still water is 16, the river is flowing east at a rate of 8 miles per hour. So the river is 80 because it's going east. What direction should we find our angle? Where our boat, ready, our boat, which is V, is 16. So 16 cosine theta, because we don't know what angle it's going at. 16 sine theta. Remember our unit circle, it's always cosine sine. Same thing with these points. So if we add them together, the boat plus the river, because the river is going to affect the boat. Boat plus river. 8 plus 16 cosine theta. And then 0 plus 16 sine theta is just 16 sine theta. Why does that look funny in my paper? I don't know. It looks fine. Are we good so far? And this is supposed to equal this 8 plus 16 cosine theta should equal 0. Now we need to solve this little mini equation. Move 8 over, divide by 16, get negative 1/2 then. Theta ends up being 120 degrees, which is all the way over here. Okay, but that's not, this is the piece that you need to do directions. So it's going north 30 degrees west. Up north first, over 30 degrees, and that's in the west direction. All right, and the last one, force, has to do with force. So then we have two forces, F1 and F2, 16 and, oh, no, sorry, 6 and 24. This is the 6, this is the 24. They act on an object at point P. What's the resulting force? Well, we have to find the actual vector pieces first. So for F1, we get 6 cosine 45, 6 sine 45, which this is 3 radical 2 and 3 radical 2. Then for force 2, it's 24 cosine 120, 24 sine 120, 120, which this is negative 12, and then 12 square root 3. Put my vector. We are, so to find the resultant force. Resultant force is when you add the two together. So F1 plus F2 equals, these must be rounded. Nearest integer, yes, they are rounded. So 3 radical 2 plus negative 12 ends up being negative 8. And 3 radical 2 plus 12 radical 3 ends up being about 25 once you round it. And that is the end of 8-4.